Chen, we're recording. Be on your best behavior. Okay, now that we fully understand use substitution. And Jason Lowe? Are you the Chinese person?
It's racist.
No, for the Chinese bento.
Oh yeah.
Why wasn't I asked?
Do you want to buy one?
Yes. How much is it?
$10.
Huh? That's all the money I have in my wallet. $8. Yes. Can I give it to you now?
Sure.
I got $1 for lunch today.
You sold 3 for 5.
Huh? Okay, today we learn integration by parts. Okay, now what if I give you an integral like this? Integral x cosine x dx. Is it on the list? No. Can I make a u substitution? And make it on the list? No, you guys know how u substitution works, right? If you let u, whatever you let u equal to, the derivative got to be in there, right? If you let u equal to cosine x, du is negative sine x, it's not there.
Alright, Mr. Park, you give me one extra.
Well, I got $2 for lunch. Yeah.
No, it's me 25.
Are you sure?
Not the 8.
I have the 9.
Oh, that's okay. Oh, okay. $1.25. Change. $3.25. I can go to Jack in the Box. 4 tacos and a chicken salad. Okay, here we go. So how do you find the antiderivative of this? What do? You gotta think. Because look, you're multiplying things, so you gotta think, oh, maybe this has something to do with the product rule. You guys remember how the product rule works? So now you kind of guess, you go, okay, wait. To get cosine x, that's the derivative of sine x. So then you go, okay, you start with x sine x. See, so what you're trying to find is, find the function so that when you take the derivative of it, you get that, right? That's what an antiderivative is. So let's try this. If I take the derivative of this, what do you get? Remember how product rule works? Derivative of the first, leave the second one alone. Plus, leave the first one alone times the derivative of the second, which is cosine x. And then go, hey, look, that thing is right there. See? So I just got to get rid of this then. So how do I get rid of this? Don't you need a minus sine x to get rid of that? Then they cancel out. So what would you have to put here so when you take the derivative of it, you get negative sine x?
Cosine.
Plus cosine x. And then you put plus c and then you're done. Oh, so Mr. Park, we just got to kind of reverse the product rule then. Yes, exactly. You got to undo the product rule. Just like when you do a u substitution, it undoes the chain rule. You know what I'm talking about? The derivative of the bottom. You guys understand this? If I take the derivative of this, look, you use the product rule here, and the derivative of that is that, this cancels that, and then this is the same thing as that. So that means this is the antiderivative. But Mr. Park, that's hard. Is there like a technique I can use so that I don't have to like think so hard? Yes, luckily for you there is. It's called integration by parts. Because some of you are like getting scared looking at this. And that's like an easy one. So yes, we have a technique. It's called integration by parts. Okay, anyway, here is the formula that's printed in your book that some of you didn't even bring the day after the test. Almost this whole first row, if not the whole first row. Anyway, here it is. The integral of u dv is equal to uv minus the integral of v du. This is the formula for integration by parts. So now we have another technique of integration. So, you know when you're given an integral, the first thing you should ask yourself, is it on the list? Because if it's on the list, then no problem, right? Next thing, can I make a U substitution to put it on the list? And then now, number 3, can I do integration by parts? And then we're going to learn some more techniques as well. Okay? Now, where did this formula come from? Well, it came from the product rule. So here, what's the derivative of U times V? What's the derivative of U times V? You know what? I'm just going to do this notation, just the D notation, over dx, but I'm going to multiply both sides by dx. So, derivative of the first, du dx, but then I'm multiplying everything by dx, yeah? Derivative of the first, leave the second one alone, plus leave the first one alone, take the derivative of the second. Remember, you can treat these things like fractions as well. Now, how do you think I can get this from this? What am I going to do? One of these I'm going to move on this side. Which one? Which one am I going to move on this side? The first term or the second term? Look at this. Look, v du. Put it on this side. So you got the derivative of u times v minus v du is equal to u dv. So what do you do now? How do I get from this step to that step? You integrate both sides. What's the integral of d, the derivative of u times v? uv. Yeah, you just get uv. They cancel each other out. The integral of the derivative is just the same thing. Minus the integral of v du is equal to the integral of u dv. And that's how you derive this formula, which I'm sure you don't care about. Anyway, in AB, you just have to know how to use it. Okay? And again, how do you use this? This is a technique like U substitution. You gotta do dozens of problems so that you get good at it. Okay, you guys remember this answer? I'm gonna erase it now. Okay, so this is how integration by parts works. Okay, so every problem tonight, you're gonna make this chart. Okay, so one of these parts, see how the integral is in parts here? One of these parts is gonna be the u, and the other part is gonna be the v. So you have, by doing the homework, you get the feel of which one should be which. Because sometimes it doesn't matter, but sometimes it matters. Okay, I'm going to do the wrong way first, just so that you can see. What if I let u equal to cosine x and dv equal to x dx? Okay, fill in the chart now. What's the derivative of cosine x? Negative sine x dx. Don't forget to put these dx's on. Some of you paid the price yesterday. And if dv is x dx, what is v? That means you got to do antiderivative, right?
1.
Antiderivative.
Oh,
1/2 x squared. Plus c. We're just going to put the plus c at the end. Do you see how to fill in this chart? To go from u to du, you take the derivative. To go from dv to v, you do antiderivative. And then now all you have to do is plug it into this formula. Okay, so the integral of u dv, this times this, which is the integral that you're trying to find, right? Is equal to u times v. What is u times v? This times this. Minus the integral of v times du. What is this times this? What's this times this? The negative half can be thrown on the outside, and then you're going to have x squared sine x dx. Okay, now, so in order to do this integral then, you have to be able to do this integral. But can you see that this integral is harder than the one you started with? See how this one has only x, that one has x squared. Yeah, so what? That's the wrong way then. You want to do it so that this integral here is easier than the original integral. So we picked the wrong way. Okay, so that means, so you erase, but that's part of the learning, people. Oh, that means I put the x here, and I put the cosine x dx there. Okay, now fill in the chart. What's the derivative of x? Now is the time, Tsunaki. 1 dx. And then over here is antiderivative. So can you see why this way was better? Why is this way better? Because when you put x over here, you take the derivative, it becomes 1. If you put the x over here, you have to do antiderivative. You get 1/2 x squared. It's more complicated, right? Okay, now we just throw it into the formula. The integral of u dv, which is the thing you're trying to find, is equal to u times v minus the integral of v times du. Is this integral doable? Yes, that's on the list. So we have x sine x minus, and what's the integral of sine x dx? What's the antiderivative of sine x? You just took the test yesterday. Negative cosine x plus c. And there's your answer. Isn't that the same thing we had from before? Yeah, but see, but this is a technique where you don't have to think as hard. So the integration by parts, what it does is it undoes the product rule. Just like u substitution undoes the chain rule. Okay, you guys get it? Yeah, well, this is an easy example. Now let's kick it up a notch. I'll leave that on the board since that's the formula. You gotta know. Okay, now we're gonna spend 2 nights on this homework. So, who has the homework assignment? Is it already split up into 2 parts?
6.3, 1 to 13 is 15, 17, 15,
No. Okay, so we're gonna spend 2 nights on this. So, do half, whatever that is. Okay, and I'm sure this problem I'm showing you now is on the homework. And I'm sure somebody's gonna write it on the board on Monday. Okay, integral of tan inverse x dx. What? What are we? Okay, so this is what you gotta do. Okay, well you know you're gonna use integration by parts, but in real life this is what you do. Is it on the list? No. Can I do u substitution? No. So then you try integration by parts. So you make the chart. Okay, now one of these parts is going to be u, one of these parts is going to be v. dv. This dx has to go over here, so you really have no choice. The tan inverse x has to go over there. You know what I'm talking about? You have to split this integral up into parts. One part goes here, the other part goes there. But this one is easy because there's only one thing. See, like if there was an x there, then you got to decide, does the x go here or does the x go there? But this one's easy. You have no choice. Okay, fill in the chart. du is the derivative of this.
1 over x squared plus 1.
Okay, dx. And then what's the antiderivative of 1? Okay, so use that formula. The integral of u dv, which is the thing you're trying to find, is equal to u times v minus the integral of v times du. This times this. X dx over 1 plus x squared. So in order to do this integral, you got to be able to do this integral. Can? Is that integral doable? Huh? How do you do this integral here? U substitution. You guys are supposed to be experts at it already. U equals 1 plus x squared. Some of you are still hazy, huh? Oh, I thought we don't have to know it anymore. We took a test on this. 2x. We're going to be doing this the rest of the year. This U substitution is the single most important technique on the AP exam. You don't know how to do U substitution, you're going to fail the AP exam. That's how it goes. Okay, so this becomes the integral of u on the bottom, and what is x dx? du over 2. Some of you, you're still putting 2 here when it's supposed to be 1/2. If you move the 2 on this side of the equation, it's a 1/2. Ah! And is that integral on the list? Yes, that's 1/2 natural log absolute value of u plus c. Resubstitute back in 1/2 natural log of 1 plus x squared plus c. Mr. Park, what happened to the absolute value? Yeah, you don't need it because 1 plus x squared is always positive. Think about it. If you square any number and you add 1 to it, it's positive, right? So you don't need it. However, if you want to put it, I guess you can put it if you want, but that's just like saying, how old are you? Oh, absolute value of 18. It's just dumb, right? Okay, so now let's write our final answer. X, tan inverse x, minus that thing right there, which is 1/2 natural log 1 plus x squared plus c. Okay, this would be an example of a medium problem. Could you have thought of that on your own? Pretty tough, yeah? So that's why we have integration by parts. So does everybody understand how this thing works? In order to do this integral you get over there got to be doable. So that's what you have to figure out when you do your homework tonight. What part do I have to put where so that this integral becomes doable? Okay, let's do another one. Integral x natural log x dx. Oh, let's make it x squared. Kick it up a notch. Okay, is it on the list? No. Can I do u substitution? No. So we're going to do integration by parts, make the chart. You know, after a while, after you do like 5 or 6 problems already, this chart, after a while you don't even write this already, right? You just, okay, whatever. What do you think? Okay, now this one got 2 things. Okay, the dx always is going to go here. So do I put the x squared here and the ln x there? Or do I put the ln x here and the x squared there? What do you think? So think, okay, let's see if we can get it right on the first one. Should I put the ln x here and the x squared there? Or should I put the x squared there and the ln x there? What do you think? Okay, well, this one.
Yeah.
Okay, let's try. So, what's the derivative of x squared? 2x dx. Okay, now, what's the antiderivative of natural log x? No, the antiderivative. Anybody? Chen? Special forces. Take out the dagger. That's right, nobody knows the antiderivative of ln x. That's right, so that's why we can't do it this way. Exactly. The antiderivative of ln x is not on the list. So you really have no choice. You have to put the ln x there and x squared there. Because a lot of people think you put the x squared here, then when you take the derivative, the power goes down one, it makes it easier. But the problem is we don't know the antiderivative of ln x. We know the derivative, I think, 1 over x dx. And the antiderivative of this is 1/3 x cubed plus c. We'll put the plus c later. So, using the formula, the integral of u dv, which is the thing we're trying to find, is equal to u times v minus the integral of v times du. Now what happens when you multiply this times this? You can show the 1/3 on the outside, and what is 1 over x times x cubed? X squared dx. Is that integral doable? Oh, that's the easiest one, right? X to the nth power. So your final answer is 1/3 x cubed ln x minus, what's the integral of x squared? Come on. Make the power 1 bigger. 1/3 x cubed times 1/3. No. 1/9 x cubed, and then please don't forget to put the plus c. There you go. It's a technique, people. A technique means with practice you can get good at it. But you actually have to do the practice part. Okay, now we're ready for a harder problem? These are all medium level problems. Okay, you guys think you're good, yeah? What did we do? We did cosine, let's do sine now. No, in fact, let's make it even more challenging. Put sine 3x. Yeah. Okay, so no, it's not on the list. Well, you know you're going to do integration by parts. Okay, fill in the chart. Okay, what do you think? What should I put here? Come on, you had a little bit of experience. The x squared goes here. You put the trig function here. Okay, fill in the chart. 2x dx, antiderivative here. Negative 1/3 cosine 3x. Okay, use the formula. The integral of u v, this times this, which is the thing you're trying to find, is equal to u times v, negative 1/3 x squared cosine 3x, minus the integral of v times du. What happens when you multiply this times this? You get negative 2/3, which can be put in the front, and then you have x cosine 3x dx. So in order to do this integral, you got to be able to do that integral. Yeah, that looks like the very first example we did. So how do you do this integral right here? You got to do another integration by parts. You got to do it again. What? Where A, B, Mr. Park? And what would, okay, and you can kind of see what's happening here, yeah? What if this was x cubed? 3. You got to do it 3 times. What if that's x to the 4th? You got to do it 4 times. So look at your homework. Isn't there one with x to the 7th over there? You got to do it 7 times.
Can you do that one?
Unless, wait. So Mr. Park, you're telling me when you have like a polynomial here and a trig function there, or a sine or cosine, then if it x to the power, that's how many times you got to do it? Yes. Unless there's a shortcut. Yes, there's a shortcut. It's in the book. Usually I don't teach it on the first day, but I feel sorry for you guys. I'm going to teach you very because I want to let you guys do it 2 or 3 times just to see. You know what I'm talking about? But Teruya, you wouldn't even do it anyway. So I'm going to teach you the shortcut on the first day, but this shortcut doesn't work all the time now. It only works in certain situations, okay? So what situation is that? Well, instead of doing integration by parts twice, we do this thing called tabular integration. Now every year I teach this to the students, well it's in the book, and then they go to college. And when you take second semester calculus, most of what I taught you is review, yeah? So when you get this problem, they do tabular, and the professor always goes, what the heck are you doing? And then they're always interested in to know like how we did it. Oh, it's in the book. Okay, now watch. Okay, so one part you're gonna put here. So this, you put the polynomial here, you put the trig function there. It doesn't have to be that. Now in order for this to work, you have to take the derivative of this down to 0. And the only time that's going to work is if that's a polynomial, right? If you have a polynomial, if you keep on taking derivatives, you're going to hit 0 sooner or later, right? Yes. Watch. What's the derivative of this? 2x. Take another derivative. 2, another derivative. 0, see? If it's a polynomial, you will hit 0 sooner or later. And then in this column, you have to be able to repeatedly anti-differentiate it. So what's the integral of this? Negative 1/3 cosine 3x. We're not going to put the plus c to the end. Then you do another integral. Negative 1/9 sine 3x. And then you do another antiderivative. 127 cosine 3x. So you get it? In this column, you do derivatives. In this column, you do antiderivatives. In fact, since Extended is next week, we're going to finish watching the movie. Remember that? You guys don't remember, but Jaime Escalante did this on the board. He goes, it's so easy. So, remember the thing he did? Tic-tac-toe. So we're going to watch it again. So watch what I do. So starting from this upper one, you come down like this. And then plus, minus, plus. You always alternate the signs. Okay, now once you do this, you can write the answer. So the answer is going to be this times positive 1. That's the first term. What is this times positive 1? That's the first term. Second term is going to be this times negative 1. So, plus 2/9 x sine 3x. And then the last term, this times positive 1. Plus 2/27 cosine 3x, and then you put the plus c. Now, isn't that a lot easier than doing the thing 2 times? Way easier. Way easier. But again, the only time you can do tabular is when this one is a polynomial and this one can be repeatedly integrated. Otherwise, you can't fill in the chart. So you have to fill in the chart all the way to there. So if you cannot integrate this thing 3 times, then you can't do it. Okay? So, what if I give you this? Integral x cubed, like on tonight's homework, e to the 2x dx. Can you do tabular on this one? Yes, because this is a polynomial. You take the derivative down to 0. What about this? Can this be repeatedly integrated?
Yeah.
Yeah, so this is a perfect candidate for tabular, unless you want to do integration by parts 3 times. I don't want to. So this column, you keep on taking derivatives till you hit 0. Go. This side, you do antiderivatives. See, so if you cannot keep your derivatives and antiderivatives straight, it's a hard time, yeah? And then you just go booga, 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 plus, minus. You always start with plus. I think Jaime Ascalante did this. Tick, tack, toe. He was showing Pancho. But everybody knows he's the dumbest. Okay, so the answer is going to be this times positive 1. 1/2 x cubed. Don't worry, we're going to rewind it to that spot. This times negative 1. So minus 3/4 x squared e to the 2x. And then this times positive 1. So that's going to be what? 3/4 x e to the 2x. And then this times negative 1. So that's minus 3/8 e to the 2x. And don't forget to put the plus c. That should be automatic already. Okay, so since I taught you the shortcut on the first day, no excuses, yeah? No, because I really want students to do this 3 times just to see how much pain you have to go through. And then when I show them the shortcut, then they're all happy. Actually, last year they were mad. They went, how come you didn't show us this yesterday? Because you have to go through pain sometimes. Okay, let me pass back the test.